This is a lesson from Monday, December 14th, 7-7, covering topics factoring, difference of squares, and trinomial squares. We're working out of the Big Ideas book, page 401, number 1 through 22 all, and 35 through 40 all. You might want to stop the video after I've discussed difference of squares and do number 1 through 14 of the homework. And then continue watching the rest of the video for the perfect square trinomials. All right, so last week we were given a binomial by binomial and we multiply it out, something that looks like this. They look exactly the same except they have opposite signs, and we found that when we do this, we get x squared minus 3x plus 3x and minus 3. When you combine your like terms, we find that my inner and my outer terms end up canceling each other out. We are left with just x squared minus 3. Now, what we call that is a difference of squares. So I'm going to actually skip this and move on to how do we actually solve this lesson. Okay, so when we're given the actual difference of squares, when we're given this difference of squares, we know that this is what it looks like, so we're going to just be going backwards. And here's how we do that. If there's only two terms, the only kind of binomial that can be factored is one called a difference of squares. If it is not a difference of squares, it cannot be factored. And so what that means is it has to actually look like this, where you have a perfect square minus a perfect square. So again, we said here's the perfect square. We have a different sign and a perfect square. Okay? Now, if that's the case, the first thing I'm going to do is I look at the first term. How do I get x squared? Well, I obviously have to multiply x times x. What's the square root? So if I'm looking at this, I'm looking at the square root of x squared. Okay, what's the square root of 9? That would be 3. So I place that. And then the pattern to make that inner term and outer term disappear is one of the binomials is plus and the other one is a minus. So it's as easy as that. So let's try it. Okay, let's go through one more. I'm going to make my binomials. Make it equal to the square root of m squared is m. The square root of 49 is 7. Notice if the 49 is in the second place of the binomial, I'm going to keep that. Its factors in the second place. And the signs will be opposites. Now pause the recording and see if you can do the next few. Now check your work. I've got y minus the square root of 100 is 10. Okay, that's 1 is a minus, 1 is a plus. Okay, I've got the square root of t squared is t. I've got an 8 plus a minus. Now, just because they're both variables, don't get worried. Remember, I'm placing the square root of x squared as an x. The square root of y squared is a y. One's plus, one's minus. And it doesn't matter, I could make the first one minus. Now, since that constant term is first, I'm going to keep it. The square root of 16 is 4. Put it in the first place in each binomial. The square root of k squared is a k. And then one's a plus and the other's a minus. Or I can switch it around, it doesn't matter. As long as we have opposite signs. Okay, the last one, you have p, square root of p squared, and the square root of 1 is 1. One's plus, one's minus. Okay, pause the recording if you need to check your work. All right, so there are 5 types of factoring. The first thing we always do before we start factoring is we look for a GCF. I haven't really introduced it yet, but it's going to be the first thing you ask yourself, is there a GCF? Other types of, and this kind of goes along with all of these others. We check for our GCF, and then it's either a difference of squares, a perfect square trinomial, regular trinomial factoring, or trinomial factoring with this lead coefficient. But this GCF could be part of each of those. So let's take a look. All right. Our difference of squares, we know that it's made up of a perfect square minus a perfect square. So we should have 2 binomials that are opposites. Now the thing about this is that I want you to memorize your numbers up through at least 20 and then the number 25. So, because these are numbers that will come up all the time and nobody wants to wait, just like we don't want to wait for you to say, what's 7 times 8? It's 56. We need you to know these perfect squares. Now, through 12, your perfect squares through 12 should be easy. Because we're basically saying 1 times 1, 2 times 2, 3 times 3. 1 times 1 is 1, 2 times 2 is 4. The next one is 9, 16, 25. How am I getting those perfect square numbers? I'm just multiplying in order. A number by itself. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared. So we know it's 1, 4, 9, 16. We have 25, 36, 49, 64, 81, 10 times 10 is 100, 11 times 11 is at 121, and 144. That's 12 times 12. Now those should already be memorized. So really the only new ones are 13 squared is 169, 14 squared is 196, 15 squared is 225. Oops. I want you to memorize 15 squared is 225. 16 squared is 256. Okay, 256 is 16 squared, and then we're at 289 is 17 squared. 18 squared is 324. 19 squared is 361. That's supposed to be 361. And 20 squared is 400. Another big one that comes up is 625. So the bare minimum, I need you memorizing these. And these are really only the new ones, so it shouldn't be that much more. It does come in handy to, Miss Sophia has people memorized to 27, but these are the bare minimum. Knowing those others will definitely help you. I think 24 times 24, I see that quite a bit. Okay, so let's move on. Now let's do some factoring with the difference of squares. So, number 1, we've got, remember we make our 2 binomials. We take the square root of x squared, and that's x times x. The square root of 81 is 9 times 9. And if it's 2 terms, they have to be opposite to get rid of that inner and outer term. In the next binomial, we've got 9m squared minus 121. Now I know it looks kind of difficult because there's a coefficient of the m squared, but they're both perfect squares. So in that case, again, I'm doing the same thing. The square root of 9m squared is 3m times 3m. That would give me 9m squared. The square root of negative 121 is 11. And I've got one that's a positive and the other that's a negative. All right. Now pause the recording and see what you can do for the next few. Now check your work. So you can see we have one where our constant term is first, so that's going to be 4 and 4. And we've got 7k, 7k. One's positive, one's negative. Now this one's a little bit different. Okay, what's the square root of k to the fourth? What times itself is equal to k to the fourth? And so we know that that's got to be k squared times k squared. Remember, we add the exponents. And the square root of 4 is 2 and 2. One's positive, the other's negative. Number 5. Square root of t squared is t and t. And what's the square root of 50? We're finding that that 50 was not on that list of perfect squares. There's no number times itself, no whole number times itself that equals 50. So when you get to this situation, this is where we say that it's not factorable. Okay? Because there's no perfect square times itself that equals 50. All right, next one. Actually, let me erase all this and I'll just add them. Is 2x plus 7 times the quantity of 2x minus 7. Next one is 6y plus 1 times the quantity of 6y plus minus 1. And last but not least is the biggest trick of all. This is what I will throw at you, what every teacher will throw at you, is this last one. And that is the biggest granddaddy trick of all is this one right here. Because remember what I said, the only binomial that you can factor that's really factorable is either a GCF, and there's no GCF there, or a difference of squares. And this is not a difference of squares, it's a sum of squares. There is a plus sign. Because it has a plus sign, this is not factorable. There is nothing that will allow you to eliminate that inner and outer term. Because remember, when I have those two x plus 3 times x minus 3, I end up with, or let's say, some people want to do 4x plus 5 and 4x minus 5. That would multiply to 16x squared minus 25. Let me add this here. Again, it was 16x squared minus plus 25. So we've tried 4x plus 5 times 4x minus 5. We get that that equals 4x squared, 16x squared. Wait a second, what was my original problem? Yeah, 16x squared. We've determined that that's 16x squared minus 25. Can you think of another? What if we tried 4x minus 5 times 4x minus 5? We know that doesn't work, and so now I've got, that gives us 16x squared minus 25 minus 20x minus 20x plus 25, oops, plus 25, and that simplifies to 16x squared plus, sorry guys, plus 40x, minus 40x, sorry, and then plus 25. So there is no way, and if I did a plus plus, we would end up with plus 40x plus 25, 16x squared plus 40x plus 25. So there's no way to get that binomial 16x squared plus 25. So with that in mind, this is what we say when we get something with a plus sign, a binomial with a plus sign. We say not factorable, not factorable. Please do your best to not overuse that word. Single most overused word second semester. It's kind of like the equivalent to. Now, like I said before, this is how you may, when we get past the factoring chapter and we just start seeing different expressions, you might see something that looks like this. And so the first thing we always ask ourselves, is it possible? Is there a GCF? And so, yes, I see that 2x squared and negative 50 both have a common factor, and that is 2. So first I'm going to GCF pull out the 2, and so what I'd be left with is x squared minus 25. And then we notice what's left inside the parentheses is something that is a difference of squares. So that then needs to be broken down to x squared, x squared breaks down to x times x, and 25 is going to be plus 5 minus 5. And there you go, it's fully factored. If you multiply those things together, then you would get 2x squared minus 50. Now another big one, and I promise to put this on a test, I may even give you something like m to the 16th minus 1 is something like this. So let's first start with this. The square root of m squared, m to the 4th is m squared. And the square root of minus 1 is, of 1 is 1, and putting it there. And remember, we have a plus 1 and a minus 1. Now what I want you to notice is this one right here. We are now left with why I can't do that. We are now left with this difference of squares here. So remember, it's got to be fully factored. Fully factored is the key here. We've got m squared plus 1. And now we can break this one. Let me change colors for you. We can break this one down to m plus 1, m minus 1. So don't forget, we have to fully factor or you do not receive credit. That's another big mistake that people make while factoring. Okay, pause the recording. Let's see what's next. I think we're on to our next section. No, let's try and practice a little bit more. So now we're going to kind of mix it up. So why don't you pause the recording and try and finish these 4 up. Now check your work. So step 1, this one requires some GCF factoring, 3, and I'm left with y squared minus 9. We know that this breaks down to y plus 3, y minus 3. Fully factored, you are done. Number 2, we've got x squared makes x to the 4th plus 9 minus 9. Don't forget, we rewrite the original piece, and then what's still factorable is this difference of squares right here. I'm going to make it smaller. Fully factored. Okay, let's try the next one. We can divide out a 5, and I've got m squared, no, m to the 6 minus 4. Now this one gets tricky. M to the 6 is really made up of m to the 3rd times m to the 3rd. And this is plus 2 minus 2. Now, note that m to the 3rd is not a perfect square because no number times itself would equal m to the 3rd. We can't break it down anymore. It has to be an even number up there. like m squared, m to the fourth. I could break them up into the next two. So we are done here. Next one is 5, and I'm left with y to the fourth minus 16th, my favorite kind of problem. We've got 5, and this now breaks up to y squared plus 4 times y squared minus 4. Are we done? You guessed it. Nope. We're left with a difference of squares. 5 times y squared plus 4. But remember, this then breaks down to y plus 2 times y minus 2. It's kind of like a puzzle. What are all the pieces of the puzzle that make it up? And here, if I multiply those all together, they would then equal 5y to the fourth minus 80. All right, so pause the recording and I'll do part 2. On a separate recording.